they term that. But with the level of significance, that's a number that you want to stick to. If your null, if your null is higher, or if your null is low, then you reject your hypothesis null, and you accept your alternative hypothesis. Is that correct? I think that's correct.
Yeah, I think so.
So that's how that works. If you change your level of significance, it's because you decided to have a bigger window where you want, I don't know how to explain this. I wish I had better words.
So is this just to reduce your the probability of an error? Is that the idea?
Kind of.
Okay.
Because, yeah, probability of an error is a little bit different. But the thing, normally, I don't think we'll ever change our level of significance. They would tell us that our level of significance is a certain amount.
Okay. All right.
Yeah. Does that make sense? I don't know if that makes sense.
It does. It helps.
In a way.
It helps put it in.
Thanks, Christy.
Its little box where it's supposed to go.
Yeah, let me find the proper words for it, because that was not a good. P-value. I want to requirements. There we go. Summarize relevant background information. And they don't have it on here. Fantastic. What I've always wanted.
Google it.
So, what was it? So the level of significance has to do with the percentage of how right you want it to be, how close to accurate. I don't have the right words. Let me think about it, and then I'll give you a perfect definition. But it has to do with the level, and you choose that as you're researching. So for our problems, they will always almost tell us what our level of significance is. We'll never choose for ourselves what that is.
So we just have to decide if we want to increase it or decrease it. We won't ever have to figure out how to actually change it.
No, we don't even have to increase it or decrease it. We never increase our level of significance or decrease it.
Okay.
The reason why our signs are the way they are, like when you're talking about when it says that the sample, or like when it's talking about the null hypothesis, is that what you're talking about?
Well, there was a question on the homework number 10. It says if we wanted to decrease the probability of making a type 1 error, would we need to increase or decrease the level of significance?
Oh, but that's a definition of something.
And the question before was testing a hypothesis and talking about the probability of committing a type 1 error.
Yeah, so you're talking about type 1 errors and type 1 and type 2 errors. Somebody knocking on my door? No.
So I looked something up online, and maybe this will help a little bit. It just said the significance level, also denoted as alpha, is the probability of rejecting the null hypothesis when it is true. And it says, for example, a significance level of 0.05 indicates a 5% risk of concluding that a difference exists when there is no actual difference. And then the significance level determines how far out from the null hypothesis value we'll draw that line on the graph.
Okay.
So the definition that you're having, that's one of the actual definitions for either of type 1 error or a type 2 error. It's not the fact that you actually decrease the alpha or increase the alpha.
Okay. All right. That helps. Okay. I'm ready to get started if you all are.
Let's do this.
Okay.
So enthusiastic.
Yay! I love statistics.
Are we? Do we have it all open?
Yeah.
Yep, I got it.
Okay, I can start with question 3.
Okay.
I have a hypothesis test consists of 2 hypotheses: the null hypothesis and the alternative hypothesis. Which one represents the status quo?
The null.
Yes, correct.
Yay, I got one right.
Woo! We're gonna get all 20 right, just saying.
Okay, we are. That's right, we are.
We have to stay positive.
Which hypothesis involves equality? And that would be the null, correct?
Yeah.
Yep.
Yeah, because the null always equals something, right? It's the alternative that might be something different.
Correct.
Yeah. Yay.
Okay. The p-value is a probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing this possibility, which hypothesis do you assume to be true?
The null.
Yeah. The null is always what you assume to be true, right? Unless
Right.
it's proven not true.
Right.
Yeah.
Okay.
Great.
Okay, and the next one is suppose the null hypothesis is mu equals 10. Use this information to answer questions 6 through 8. 6. Which of the following represents the alternative hypothesis for a two-tailed test? That would be the does not equal one, right?
Correct.
Yeah. Yeah, because it's either one side or the other.
Yep, that's right. I have the thing in front of me. Which of the following represents the left tilt test? And that is the one that goes like this.
The mean is what?
Whichever, that's the first one.
Yeah.
Yeah.
So you're saying the mu...
Eating the 10.
Yeah. So the mu is less than 10.
The mu is less than 10.
Yes.
So it would be left-tailed.
Yes.
Okay.
So I'll do 8, which is the following question represents the alternative hypothesis for a right-tailed test, and that would be, are you calling it a mu?
Yeah. So the little u is called a mu.
Oh, okay. The mu.
I want to call it a pew because it looks like a P and a U. They didn't ask me to name stuff, okay?
Okay, the mu is greater than 10, the second one.
So
Yes.
then it's right-tailed.
Yep.
Yes.
Okay.
Who's next?
Kristen.
Okay. Number 9. The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Use this information for questions 9 through 10. Okay, which relationship would result in failing to reject the null hypothesis? And that would be when it's greater than the level of significance, right?
Yeah.
No, we when their p-value is low, we reject the null. They rhyme. Right?
Yeah, that's the little rhyme.
What is it?
P-value, when our p-value is low, we reject the null. But let me double check that.
That was on the video, the answers, the video questions and answers thing.
What do you mean the video?
The one where he answers the questions to the assignment.
Oh, I watched that, but I didn't hear that.
Yeah, he even wrote it on the board.
What? Okay. I must have not been listening. That's interesting.
Yeah, so it is right. When it's low, you would reject the null.
Yeah.
Okay, so then that would be the second one, p-value less than alpha.
But this is failing to reject the null. So the null hypothesis is true.
That's right. You're right, because if we're failing to reject, no. If we fail to reject the null, okay, what relationship would result in failing to reject the null? So that would mean that our null is true, that our null hypothesis is true.
Yes.
So then that would be the first one, so it would be p-value is greater than alpha. No, it would be still. I'm confused. No, it would be greater. Because if we have a low p-value, then our significance level is low, which means that we reject the null. But if we're not going to reject our null, then our p-value needs to be greater than alpha.
Yeah.
Okay.
You got that right.
So it's the first one.
Yes.
Okay.
Okay. So when they say reject, fail to reject, instead of saying that the null hypothesis is true, they just say that there's not enough evidence to reject the null, so we fail to reject the null.
So
Which just makes everything more confusing. But when we reject the null, that means that our p-value would be less. So when we reject the null, our p-value is smaller than our alpha. But because we are failing to reject the null, it would have to mean that our p-value had to be greater than alpha.
Would it always be greater than alpha to, wait a minute, what am I saying? Because usually those alpha values are really low. So
Right.
Is that the only situation where the p-value would be considered low? Or would you compare it to the original mean or something?
No, we're only comparing it to our alpha that is given.
Okay. All right.
Is that right, Kirsten?
Yes.
Okay. And so for number 10, go ahead. What happened, Christine?
I said, how come you didn't ask me? Your different language?
We should have learned this in middle school. This way we'd probably be able to do it now, but apparently they didn't think it was important enough. So for number 10,
So this one would just be the opposite.
Yes.
Yeah.
Okay, I got that.
So it would just be the second one.
Okay.
And we're 50% done. Woohoo!
Woo! Okay, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about 1,500. They are concerned the true mean is actually higher than this. Use this information for questions 11 through 12. Which of the following would be appropriate alternative hypothesis? So we're asking, the thinking is the true mean is actually higher than. So we would want the average claim amount is not even. No, is less than.
Greater than 500.
Oh, yeah, because you say, yeah.
Well, wasn't that their number, though? They're saying the average claim number was about 1,500, so then...
So our null hypothesis would be HO equals 1,500 because that's the status quo. That's what with everybody, that's what the average is. But they're concerned that the true mean, or like, it actually is higher than 1,500. So their alternative is saying that we think that we are actually, it's going to be larger than 1,500.
Okay. So then we'd want the average claim amount is greater than 1,500.
Yeah. Okay. Yes, I understand this. Isn't this marvelous?
I think the only time that you would use equal if it says not equal or different than. So if it said different than, then we would use the one that said equal, not equal.
Well, we'd probably never use equal to, because what would be the point of that?
So equal will only be used on your null hypothesis.
Yeah.
Right. Yeah.
But nothing wouldn't be in anything else.
And then not equal, you don't really care whether it's higher or lower.
Yeah, you just don't think that's what it is.
Yeah, you just think it's different than the amount, than the...
Yeah.
Okay.
Which of the following would be the appropriate null hypothesis for that sign?
Equals. Average claim amount is equal to 1,500.
Yes.
Yep.
Okay, and then the next one is the insurance company randomly selects 40 claims and calculates a sample mean of $1,650. Uses information for questions 13 through 15. Number 13, the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes, it is, because it's over 30 subjects, right?
Yep.
Yeah.
The central whatever, central limit. See, I know some stuff.
So it's a central limit theorem, and then which of the following is a test statistic as defined in the lesson?
Oh, so number 14,
Oh, sorry.
central limit theorem.
Yeah,
Okay.
right?
So,
That's,
so we're moving on to 15.
yeah.
Okay.
Oh, so then the 15 has nothing to do. Oh no, it does have to do with this problem. So which of the following is a test statistic as defined in this lesson?
Test statistic. Oh, wait a minute. I got to read it again. Well, the only statistic we have is the sample mean.
Yeah.
Well, it says in the textbook, it says where Z is the test statistics, X bar is the sample mean, mu is the population mean, and sigma is the standard deviation, and n is the sample size. So I think it's Z.
I agree. So go ahead, read it.
Yeah, I basically just read it straight out of the textbook.
Yeah, I read it. It's on it's 4.3.2 relationships to alternative hypothesis.
Uh-huh.
And it says in the case of a right tilt test, the p-value is the area to the right of the test statistic, and that's Z. Okay, it's Amy.
So that's got nothing to do with the question, though. That must be a mistake. They're saying questions 13 through 15.
Well, I don't think it really has any. I didn't think there was anything to do with that.
Because it says as defined in the lesson, right?
Yeah, they must have made a typo. It's a
So you're just saying it's a Z value, or the Z score.
Yeah.
No, the score is different.
Say that again?
The Z score is different, right? Z is just the.
Are you in the textbook, Eloisa?
Yeah.
Go to 4.2, where it says test statistic, and read the last paragraph.
Oh, okay. So where Z is a test statistic, that's a terrible way to. X bar is the sample mean, mu is the population mean, the standard deviation, and n is the sample size. Based on the results from the formula above, X bar is over 6 standard deviations below the mean.
Got it.
So it would be. So you're right. It would be.
So maybe when they're saying defined in this lesson, they just mean less than 9 in general.
Yeah.
But it is the Z score because that's how you find that. You use that formula to get the statistic. That's what they're showing right there.
Yeah, you're right. It's just if weirded me out. No, you're right. It is a Z-score.
Excuse me, just a minute. Sorry.
No, you're fine.
Okay,
Thanks
it's
for
my
showing
turn.
me that, Kirsten.
What?
Thank
Is
you.
it my turn to read something?
Do we want to wait for Christy, or is she back?
Oh, okay, sure.
I'm here.
We ready to move on to 16?
Yep.
Okay, the historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypothesis. The null hypothesis is equals $150, and the alternative hypothesis is less than $150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts in her store and computes the sample mean at 144. Use this information for questions 16 through 18. What is the z-score associated with this test? So we have to find the z-score, and we have a sample.
Okay. So it's a 144. Never mind, I got it.
What's the sample size? Oh, 36.
Yeah.
Okay, I'm going to be slow. Sorry. I got a negative 0.9. Is that even close to what?
That's what I got.
Yep.
Okay. I'm glad. So we just had to find the z-score. That's it?
Yep. Now, what
And
is
then-
the p-value associated with the z-score?
So yeah, it is a z-score. What is a z-score associated with this test? So would we point? So it'd be negative 0.900.
Yeah.
That seemed too easy, didn't it?
Yeah.
And then the p-value.
So we find that by using the applet.
Okay, so this is where I have questions. How do we know what to highlight? Because I know sometimes you do.
I think it has to do with whether it's greater than, less than, or not equal to.
Okay.
Yeah, if it's less than, then you highlight like the right, everything beyond the right of the z-score.
Okay.
If it's greater than, you highlight everything to the left. And if it's two-tailed, then you highlight both ends.
So this one, she thinks the average has decreased. So she thinks it's less than. So we're highlighting Just the left?
Yes.
Okay.
So I got 0.1841.
That's what I got too.
So
What was it?
0.1841.
Okay.
that's 0.184. What we put in there.
And when it's only the left?
Yes.
That's what I did.
0.184.
Yeah.
Okay, got it. So our alpha value is 0.05, and our p-value is higher than that. So then we failed to reject the null hypothesis.
Yes.
Yeah, that's what I would say.
Yeah.
Okay.
Number 19, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null when the null hypothesis is true? I just wrote this down.
Type 1?
Yeah. Type 1 error is when you reject the null that is really true.
Yep. That little chart is useful, man.
That little four-square thing?
Yeah.
Oh, I think it's kind of confusing. Maybe I just haven't looked at it enough. I just wrote down the definition of a type 1 error. I need to study that chart a little bit more, I guess, because it's kind of confusing.
Well, you'll know what works for you.
Well, I'm sure at some point we're going to have to know that chart, so I better learn it.
You just write it really small on a piece of paper. Start doing your test.
Start my next unit test notes.
I'm going to do that.
Okay, we're moving on to number 20.
Yep.
Somebody want to read?
A researcher decided that instead of using a level of significance of alpha, 0.05, to use alpha equals 0.01, which of the following will be true? The probability of a type 1 error will increase, the probability of type 2 error will increase, the probability that the null hypothesis is true will increase, the experiment will be more scientifically valid. So,
well, it's not the third one, right? Because the null hypothesis is never proved true.
Yes. No. It's not the third one.
So it's not the third one. The last one doesn't sound too likely either.
Yeah.
So in the book it states, if the alpha value is very small, the probability of committing a type 2 error will be large.
Okay, so if he's making it bigger, then the probability would...
Wait, so if a researcher said instead of using a level of significance 0.5, he's actually making it smaller.
Yeah.
Oh, he's making it smaller, okay.
So the type 2 will increase.
Okay. So automatically, if the type 1 error decreases, then the type 2 error increases?
Yeah.
Yes.
Wow. That's kind of crummy.
It really is.
Like, what kind of error are you going to make? Wow, today I got picked type 1. Okay, last one.
If alpha equals 0.05, compute the probability of committing a type 1 error.
I have no idea how to do that.
Yeah, we weren't taught this in this lesson.
Okay. Oh. Wouldn't it just be... Wait. Wouldn't it just be... Just a minute.
So if we just put, if our area is 0.05,
Wouldn't it just be 5%? That's just...
No, isn't there a chart somewhere where it has like the different things?
Yeah, I'm pretty sure I saw somewhere they were using that as a...
I thought there was a similar question, and it was like, oh, well, here, numbers, part 2 on C. It says if the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error? And it says 1% or 1 in 100 chance was that answer.
Where are you looking at?
It's on the preparation material.
Preparation, part number C, or letter C.
No, I don't have that open anymore.
Anyway, that answer was 1%.
So it says, where it says type 1 and type 2 errors, it says we choose alpha to be some small number. Is that alpha or sigma? Either way. To be a small number so that the probability of committing a type 1 error is low. The most common value for alpha is 0.05. This is equal to 1 over 20. So when the null hypothesis is true, there is 1 in 20 chance that it will be rejected at the 0.05 level of significance. Other common choices for it include 1, okay, so then 1 over 20 would be 0.0, it'd still be 0.05, so I don't, so our question is, what does our question say?
If alpha equals 0.05, compute the probability of committing a type 1 error.
Guys, if you leave it at 0.05, you get them all correct.
Did you already finish it?
Yes.
Okay. Because I'm like, I'm like, it's 5%, but that's what it already says. It already gives the answer, but... Like,
yeah, like, I think we just overthought it.
I'm like, I know what the answer is, I just don't know how to write it.
Oh, goodness gracious. Do we want to do the homework really quickly? Do you think the homework will be...
I would.
Okay, let me look at it.
I need to bring my grade up.
Homework is 10 questions. We got this, people. We got this. Okay.
Okay.
Let me know when you're ready. Did we lose Renee?
What?
How did we lose Renee?
Wow.
Out of all the people to lose, we shouldn't be able to lose her. I don't know what to do with my life now. Kirsten, I really like your hair color.
Thank you.
Maybe one day I'll meet you on campus, you know, since we live like a few blocks from each other.
Yeah, maybe you will one time.
Maybe you guys should arrange it.
We could, you know. Hey, there she is again.
Oh,
where did she go?
Sorry, I have no idea what happened. I just lost connection for no reason. But it came back. That's even weirder.
All right. Well, there's only 10 questions on this homework assignment. Let's get it. Let's kick it out. Kick it in the butt.
So did you guys get an answer for the last one?
Yeah, it's 0.05.
Who would have thought, right?
Yeah.
So it's the same. Yeah, it's the same. Okay, because I did see something like that. It's like, well, what? If it's the same, then I don't get why. Did you submit already?
Yes, you get 100%.
Spoken like a true oracle. Submit and you will get 100%. Awesome. Okay, so we're going to try the homework?
Yes.
Yeah.
Okay. So I wrote down the probability of getting a test statistic that is least as extreme as the one you got, assuming the null hypothesis is true.
That's what I got too.
Yeah.
Yep.
Okay, so which of the following best describes the notion of significance level of a hypothesis test? So, is that type error?
Best describes the notion of significance.
I don't know what that is, guys. I always think, I thought it might have been.
The alpha value is the probability of committing a type 1 error.
That's what I thought, but I wasn't sure.
Well, that's what I wrote down. That's what I wrote down from the little like review thing at the bottom. So probably of committing a type 1 error. So that would be the first one.
Okay.
But wait,
Go ahead.
what? I don't know what it's asking exactly.
For what, number 2?
Yeah.
It's just asking the definition of what the significance level of a hypothesis test is. So that's why I think it would be type 1 error. But I don't know. What are you guys saying?
I think you're right.
Okay. Well, if Kirsten thinks we're right, then I feel real better about myself.
Because she's the smart one.
Christy likes size. Like, okay. The true mean hours of sleep at night of college students in the United States is 6.2. Suppose you want to use a hypothesis test to determine whether the mean hours of sleep at night BYU Idaho students is higher than the national mean. Which of the following pairs, blah, blah, blah. So then that would be, would it be, oh, I'm not looking at the right one.
That's whether mean hours of sleep.
The second to last one?
So they're saying it's higher.
Higher. So then it would be the first one.
What?
It's greater than. The mu is greater than 6.2. Yeah, I think you're right. Because the null equals 6.2.
Uh-huh.
So we want to determine whether the mean sleep is higher than the national mean.
Mm-hmm.
So it would be greater than. Yeah, I think it's the first one.
I agree.
Wait, don't they think? Oh, never mind.
Are you sure? Do you want us to explain it?
There's an awful lot of choices there. They're trying to freak us out, I think.
No,
They go
I
straight across. They don't go from up and down.
Yeah, and the last one is not right because the null would never look. The null hypothesis would never look like that.
Yeah.
And the fourth one down, the null hypothesis would never look like that. And the second one, it would never look like that. So the only choices are every other one.
Yeah. I get it. I just had to reread it.
Okay.
I'm a little slow.
No, you're not. You're doing good.
Okay, I'll do the next one. Suppose you're conducting a hypothesis test for one mean. The significance level alpha is 0.05 and the p-value is 0.30. Should you reject the null or fail to reject the null, and why?
So our level of significance is 0.05. Our p-value is 0.3. So we failed to reject the null.
Because the p-value is greater. So the last one. See? I got that one.
Good job, Christy. You're so smart.
Thank you.
Okay, I've got 5. So suppose you're planning a hypothesis test for one mean and you know that sigma is 18. Which one of the following correctly expresses the relationship between the probability that you will commit a type 1 error and the probability that you will commit a type 2 error? So this is like what we discussed last time with type 1 and type 2. So I think it's the first one. If I somehow reduce the probability of committing a type 1 error, I increase the probability of committing a type 2 error. Does that sound right to everybody?
Yes.
It does.
Yes.
I'm just reading through the other ones to make sure. Yeah, I think you're right. I think it's the first one.
Yeah.
Do you want to read number 6, Renee?
Sure. The national mean SAT score in math is 550. Suppose a high school principal claims that the SAT score in math in his school is better than the national mean. A random sample of 72 students find the mean score of 574. Assume that the population standard deviation is 100. Is the principal's claim valid? Use a level of significance of alpha equals 0.05. State the null and alternative hypothesis. So the null, which is already established, is, or no, sorry, his null.
No, so the null would be the national mean. So it would be 550.
So it's not the first one then.
So then, no, it would be the first one, right? No, you're right. You're right. The student's mean to score 550. So it would be the last one. The student's mean SAT score is greater than 550.
Okay, so that's because that's his alternative hypothesis.
Yes.
Right.
All right, got it.
Then we saw for the z-score.
Okay, you guys ready?
No.
I'm almost there.
Just want to make sure I did it right.
Mhm. Okay. For the Z-score, I got 2.036.
Hold on.
That's what I got.
So I got.
What did you get?
2.036.
Oh, something did not go right.
Did you do 574 minus 550
Yes.
divided by 100 divided by the square root of 72?
Yeah, something must have gone wrong in my calculations.
What are we using the significance level for?
To compare our p-value for our z-score to. Or, yeah.
Oh, to compare. Okay, when we get the p-value, we got to compare it. Okay.
Yes.
Are we just highlighting the right side?
Yes.
Okay.
Okay, what was your z-score again?
2.036.
I'm not getting it. Something's going on. Okay, so let me go over these numbers again. So it's 574 minus 550.
Right.
And that was 24, right?
Yes.
Okay, and then we divide that over. Divide that over 100 divided by the square root of 72.
Mm-hmm.
And you got I keep getting 2.036.
Yeah.
That's what we got.
Okay. And then we compare this. 2.036. And then our p-value, okay, we get that. Did you guys already plug it into the applet?
Yeah.
Yep.
What did you get?
Hold on, let me. So we believe it's going to be higher, right?
Yeah.
So then we highlight the right part.
Yes.
So I got 0.0209.
Yep.
That's what I got too.
Yeah. So you do 0.021.
Okay. So then we don't do anything with our alpha, but then our null, or our p-value is low, so we would end up rejecting the null, right?
Yes.
Oh, I guess we do. We have to do. Wait. So your decision is the value. So it says we reject the null hypothesis. I can't do those THs anymore. So there is sufficient evidence to suggest that the student's mean score is greater than 550. So
that's the first answer?
No, that's the first one, right? The second one.
Second one. There's sufficient. Yeah. There is sufficient evidence. Okay.
There is sufficient, or there isn't sufficient? I don't remember.
I'm just clarifying. Yeah, because it's lower, because the p-value is lower.
Okay. Okay.
Last one.
So number 10, In another school, a similar sample of student SAT math scores was taken. The principal of the school also believed that his students scored better than the national average. Suppose this principal collected a simple random sample of student SAT scores in math. The sample data collected had a mean student SAT score higher than 550, and the calculated p-value indicated that the null hypothesis should be rejected. In fact, the true population mean of the school students' SAT scores is the same as the national mean score. What kind of error has been committed and why? So he rejected the null hypothesis, and he said his alternative was right.
Yeah, he said his students were higher. So we rejected the null, but it was true.
So it was a type 1 error?
Yes.
Yeah, I think so.
Yeah. So we've... Okay, so it would be the first one.
Yes.
Okay. I'll be brave enough to submit it.
Okay.
%. Woohoo!
Yay.
Does this time work for you guys on Thursdays?
Huh?
Does this time work for you guys on Thursdays? Because I really like it. It's better than me trying to run home for my internship. My internship is about 20 minutes away, so it's a little crazy. But if it, I mean, I can still try to manage to be here earlier. But it was just nice that I got to be in my internship a little longer today and didn't have to rush.
I'm okay with it.
It works fine for me. It
Sure.
works fine for me.
Okay, sweet.
Kirsten, how about you?
Yeah, it's totally fine with me.
It gave
Okay.
me a little more time to do my homework.
Yeah.
Yeah, same here. All right. So then we'll see each other on Tuesday at 1, right?
Yeah.
Okay.
One
Sweet.
mountain time.
1 Mountain Time, and then so it'll be 1 Pacific Time.
Actually, I'll still be here. I'll still be on Mountain Time next Tuesday, but then I'm leaving that day.
Okay.
Okay. We'll
Okay.
figure it out. Sweet.
Awesome.
All right. Have a good night.
Tuesday then. Bye.
Bye.
See ya.